Welcoming back all the grade 12s. Welcome back to it. It's Maths Master Class with Leo, and welcome to our winter classes. We've been out for a while, but we are back now. Today we are recording paper 1, November 2023, and we're doing question 2, which is your question 2 and question 3, your number pattern, right? So we're starting with question 2, and our question 2 is as follows. Starts with 2.1.1. 2.1.1. They are saying, given the arithmetic sequence, meaning given the linear sequence, which is 7 plus 12 plus 17, 7 plus 12 plus 17, and then plus, they are saying here, determine the value of T91, right? So already told that this is a arithmetic, so we can use Tn. We know that with an arithmetic sequence, Tn is equals to A plus into N minus 1 close bracket D, right? While in this case, we can see that A is represented by what? A is represented by 7 and N is represented by 91. So meaning we can say T91 is equals to A is 7 plus into N is 91 minus 1 close bracket. Now we can get the difference by saying 7 plus 12 plus 17. 12 minus 7 is 5. 17 minus 12 is 5. So our difference is 5. So in this case, I can just get my calculator and check what's the solution, which will be, in this case, 7 plus into 90 multiplied by 5. And when we say 7 plus into 90 close bracket multiply 5, what do we get? So in this case, we're getting 457. Our T91 is equals to 457, right? So, and the next question they are saying, calculate the value of, or calculate S91. 2.1.2. They want to know what is S91, right? We already know that this is an arithmetic sequence. We have two options that we can use, which S is equals to, or S91 is equals to N over 2 into 2A plus into N minus 1 close bracket D. This is our first option. Our second option is S91 is equals to N over 2 into A plus L, right? But in most cases, I prefer using this one. In most cases, I prefer using the second one, which I'll say for this one, S91 is equals to N is represented by 91 divided by 2 into 2. Value of A is represented by 7 plus into N. This is 91 minus 1 close bracket multiply by 5. Then when I punch my calculator, 91 divided by 2 into 2 multiplied by 7 plus into 91 minus 1, which is 90 multiplied by 5. This gives me 21,112. 21,112. This is my solution. Now, with this one as well, you can just say here, 91 divided by 2, value of A is 7, plus, you know what is this term? It is that term. So you'll say here, 457. And then you are supposed to get the very same value. So 91 divided by 2 into 7 plus 457, exactly 21,112. Exactly the same, right? So different methods, the very same solution. Different methods, same solution. Let me just create some space. Create some space. 2.1.3. 2.1.3, they're saying calculate the value of N for which Tn is equals to 517. They're saying Tn is equals to 517. They want to know what is the value of N, right? So we in this case, we can calculate Tn by saying We know what is the value of A. We know what is the value of D. We can say Tn is equals to 7 plus into n minus 1 close bracket multiplied by 5. This will give us 7 plus 5n minus 5, which means this will be 5n plus 2, right? Which means our formula will be 5n plus 2, and then we can now start substituting and say Tn in this case is given as 517, so this will be 517. So 517 minus 2 is equals to 5n, and then 515 is equals to 5n. Then when I divide by 5 both sides, I will get the value of n. The value of n, 515 divided by 5, it's giving me 103. That is my solution. I hope it makes sense. Let's move to the next question, which is 2.2. Right? Let's move to 2.2. The following information is given about a quadratic number pattern. Right? They're saying T1, in this case, T1 is equals to 3. T2 minus T1 is equals to 9. T3 minus T2 is equals to 21. 2.2.1 show that T5 is 111. They're saying show that T5 is equals to 111, and they're saying T1 is 3, T1 minus T2, so T1 minus T2 is equals to 9. So in this case, I'll say T2 minus 3 is equals to 9. Then T2, take this to the other side, it will be 9 plus 3, which means T2 is equals to 12. This is 12, right? And then looking for T3, they're saying T3 minus T2 is equals to 21. Therefore, T3 minus 12 is equals to 21. And then T3 is equals to 21 plus 12, which means T3 is equals to, say, 21 plus 12, I'm getting 33. Right? So this is 33. When I say this minus this, it's giving me 9. This minus this, it's giving me what? It's giving me 21. Right? Then this minus that. What is 21 minus 9? 21 minus 9 is 12. So here, I'm going to get 12 again and 12. Because this, they said, is a quadratic number pattern. They are saying this is a quadratic number pattern. So in this case, if I say 9 plus 12, I'm getting 21. If I say 21 plus 12, I need to get the next difference here. Let's say 21 plus 12, it's giving me 33. 33 is here, right? And then again, 33 plus 12 plus 12, I'm getting 45. This is 45, right? Now, I know when I say T4 minus T3, I'm going to get what? 33. T4 minus T3 or T4 minus T3, I'm getting 44. So T4 minus T3 is equals to 33. I know that T4 is the one that I'm looking for, but T3 is given as 33. This is equals to 33. Then T4 is equals to 33 plus 33, which is equals to 66. Right? Then let's look for T5. Now, the next option here, or the next value here is 66, which is that, T4. Now, T4 or T5 minus T4 is equals to what? Is equals to, let's see, 45. Right? This, I don't know it, T5 minus T4 is 66. This is equals to 45. Then take this to the other side, T5 is equals to 45 plus 66. Then let's say 45 plus 66, what are we getting? 111. Therefore, you can see that T5 is equal to 111, right? This is the method, or the easiest method, that you could have used to calculate the value of T5. Or you could have used the way of calculating the value of A, B, and C, and then substitute 5 to get that T5 is equal to 111, right? So the first solution, we got it. T5 is equal to 111 using this method, right? That was the easiest method you could have used instead of using a calculator, right? Let's move to the next question. Erase here. I'm not gonna erase this pattern. We know that T5 is 111. Now, with this, they're saying show that the general term of the quadratic pattern is Tn is equal to 6n minus 9n plus 6, right? So in this case, I'm going to start with calculating the value of A, the value of B, and the value of C. And calculating the value of A, we know that A is equal to what? 2A is equal to second common difference, which is this. In this case, meaning 2A is equal to 12, right? Then if I divide by 2, this and that, they cancel. A is equal to 6, which you can see that value of A is equal to 6 there, right? Then now 3A plus B is equal to 2 minus T1, where here, which is that. So in this case, 3 into 6 plus B is equal to 9. Then 3 multiplied, this is 18 plus B is equal to 9. And then B is equal to 9 minus 18. Therefore, the value of B is equal to what? Negative 9. Right? Then A plus B plus C is equal to the first term. And then A is 9. Right? No. A is 6. A is 6. Sorry for that. A is equivalent to 6. While B is negative 9. We don't know the value of C. But we know T1 is 3. Right? And then this is 6 minus 9 is negative 3 plus C. This is equal to 3. And then C is equal to 3 plus 3, which is 9. No, which is 6. I don't know what's happening with me today. But yeah, that is equal to 6. Therefore, you can see that if I say Tn is equal to A plus An squared, An squared plus Bn plus C. A is equal to 6n squared minus 9n plus 6, which is that, right? Which is that. Now, the last question, which could have tricked many of you. The last question, which could have tricked many of you, right? They're saying show that the pattern is increasing for all n element of natural numbers, right? Meaning n will be positive in this case. Where do we find n as positive in this case, right? So the easiest way you could have used is using calculus, right? Differentiate this, right? That is the easiest way you could have used. But there's another way. Another way is to calculate the value of B, or the turning point of this. After getting the turning point, you will see that your value of n, or this pattern, is increasing, right? So the first way is to say differentiation dTn. If I differentiate 6n, I'm going to get what? If I differentiate 6n squared, I'm going to get 12n, right? Minus, if I differentiate 9n, I'm going to get 9. If I differentiate this is plus 0, right? That is plus 0. And then from here, if n in this case, if n is greater than 3 over 4, If n is greater than 3 over 4, how do I get that 3 over 4? I'm getting it like this. Let me show you all the steps. Solving for n. Saying this is 0 is equals to 12 n minus 9. Take this to the other side. It's going to be 9 is equals to 12 n. Divide by 12. Divide by 12. This and this, they cancel. And then 9 over 12. It is 3 over 4. N is equals to 3 over 4. Right? So if n is greater than 3 over 4, if n is greater than 3 over 4, Tn is will always increase. Always increasing. For n is the element of natural numbers. Right? For n is the element, or for all n is the element of natural numbers. If n is greater than this, therefore it will increase. If it's less than this or equal to this, let's see what's happening. If I say 12 into 3 over 4, I'm getting 0, I believe. 3 over 4 minus 9. That is 0. But if it's less than that, if it's smaller than that, let's say negative. I'm going to get negatives. Right? So it will only be positive when n is greater than that. Right? I hope you understand. Don't forget to continue liking and sharing, subscribing to our channel. Let's get to question 3, which is the next question after that. So they're saying, given the geometric series 3 plus 6 plus 12, they're saying 3 plus 6 plus 12, they're saying 3.1.1. Write down the general term. This is easy. It's 1 mark. So with the general term of a geometric series, Tn is equals to a r to the power n minus 1. Right? So we know what is the value of a, but we don't know what is the value of r, but we can get it. R is equals to t2 over t1, which is 6 over 3, which is 2. Right? You can also confirm it by saying r is equals to t3 over t2, which is 12 over 6, which is 2 as well. Right? Now we substitute. Tn is equals to a is represented by 3 into 2 to the power n minus 1. That is your formula. That is your general term for the series. The next question, 3.1.2, we're given summation. It ends at k, p starts at 1, and then we have 3 over 2 into 2 to the power p. I'm saying this is equals to 98301. We know that represents as n. What do they want? Calculate the value of k such that we're given this. So they want to know what is the value of k. We know that this represents your Sn, right? By now you know that represents your Sn is equals to what? Your Sn is equals to 98301, right? We're looking for the value of k. And we know for this geometric series Sn is equals to a into r to the power n minus 1, close bracket, divided by r minus 1. That is the formula that we need to use. So let's get to it. This is 98301 is equals to the value of a is represented by what? The value of a in this case is represented by 3, right? Okay, before we say 3, let's do it here because we have our pattern. We have 3 over 2 into p, into 2 to the power p, into 2 to the power p, right? So we substitute 3 over 2 into 2 to the power 1, right? Because p starts at 1. Then again, 3 over 2 into 2 to the power 2. Again, 3 over 2 into 2 to the power 3. Last one, 3 over 2 into 2 to the power 4. Okay, 1, 2, 3, 4. Okay, now if I say 3 over 2 into 2 to the power 1. This gives me 3. You can punch it on your calculator. 3 over 2 into 2 to the power 1 into 2 to the power 1. I'm getting 3. And then the next one to the power 2, I'm getting 6. Next one into to the power 3, I'm getting 12. Last one to the power 4, I'm getting 24. Right? That is my pattern. From this pattern, what am I looking for? I'm looking for the value of r. So r will be calculated by saying r is equal to t2 over t1, which is 6 over 2, which is what? 6 over 3, which is 2. And then r is equal to t3 over t2, which is 12 over 6, which is 2 as well. You can see that, right? And then from there, we can start substituting. Sn is equals to a into r to the power n minus 1 close bracket divided by r minus 1. And then this is a is represented by 3 as we have seen that side. R is represented by 2 to the power. Instead of n, we can substitute k. Instead of n, we can substitute k minus 1 close bracket divided by r is 2 minus 1. We know that this is 98 through 1, right? And then this is like saying 98 through 1 is equals to 3 into 2 to the power k minus 1. Why? Because 2 minus 1 is 1. And then anything divided by 1 is that thing, right? As easy as that. Now from there, divide by 3, divide by 3. This and that, they cancel. I'm left with 98301 divide 3. This gives me 32767 is equals to 2 to the power k minus 1. Take this to the other side, it will be 32767 plus 1. This is equals to 2 to the power k, right? And then this will be 32768 is equals to 2 to the power k. And then if I add 1 there, answer, then I'm getting factors. This is 2 to the power 15 is equals to k. 2 to the power 15 is equals to 2 to the power k. And then 15 is equals to k. Right? That is my solution. That is as easy as you could have done that question. Right? As easy as that. You got the value of k. Then lastly, which is 3.2, a geometric sequence and an arithmetic sequence have the same first term. Okay, let's say arithmetic. Here let's say geomet. Okay, now they're saying a geometric sequence and an arithmetic sequence have the same first term. Okay, they have the same first term. So T1 and T1 here are equal. Okay, but we're not told the values of T1. So we'll say this is your X and this is your X. Right? And the common ratio of the geometric sequence is 1 over 3. R is equal to 1 over 3 here. Okay? And then the common difference of the arithmetic sequence is 3. Okay? D is equal to 3 here. And then the sum of the 22 terms of the arithmetic sequence is 734. Okay? The sum of the 22 terms of the, so in this case Sn is equals to, in this case Sn, where the value of n is 22. Let me remove that. That's 22. They're saying it's 734. Right? They're saying Sn is 734 for that. Now, let's see. more than the sum of the, okay, sum of infinity. So if we say sum of infinity, if we say sum of infinity, sum of infinity in this case, we will add it with sum of 22 terms, right? To get what? To get S22. Right? Okay. This is arithmetic sequence. This is for geometric sequence. Geometric, arithmetic. So what are they looking for? Let's see. Calculate the value of the first term. They want to know what is the value of the first term. So let's see. We can use Sn is equals to n over 2 into 2a plus into n minus 1 close bracket d, right? And then here we can say 22 over 2 into 2x plus into the value of n here is represented by 22 minus 1, right? And then from there, the difference, we're told that is 3, right? Then let's see. 11 into 2x plus 20 multiplied by 3. This will be 11 into 2x plus 60. And then 11 multiplied by 2x is going to be 22x. And then 11 multiplied by 60 is going to be 610. Okay. Let's see. I'm making mistakes. 21 multiplied by 3. Not 20. 21 multiplied by 3. 21 multiplied by 3. 21 multiplied by 3. It's 63. This is 63. Then multiply 11. This is plus 693. Right? That is plus 693. Let's check. Okay, that is it. Now let's go to geometric series. Let's go to geometric series. Sum of infinity is equal to a over 1 minus r. Right? Minus r, where we are told that r is 1 over 3. So a is x divided by 1 minus into 1 over 3. Right? So 1 minus into 1 over 3. What am I getting? Let's see. This gives me x divided by 2 over 3. Which means x divided by 2 over 3. This is like 3x over 2. Right? And then for arithmetic, we know that S22 is equals to S infinity plus S22. Right? And then this is like 22, if I remember. This is 22x, if I remember well, plus 693. This is equals to what? Is equals to, this is 3x over 2 plus, we know this is 734. Rearrange 22x minus 3 over 2x is equals to 734 minus minus 693. Then see, 22 minus 3 over 2, am I getting 41 over 2, 41 over 2x, this is equals to 734 minus 693, this is 41, then when I cross multiply, 41x is equals to 2 multiply 41, divide by 41, divide 41, this and that they cancel, x is equals to 2, x is equals to 2, this and that they cancel, therefore t1 is equals to 2, right? Don't forget to like, subscribe, and share the content with your friends. See you in the next video. Dango means thank you. Dango.